So chapter 11, we're going to go through quickly. And we skipped some stuff. We skipped 10, which is sequences. Actually, we skipped like 8, 9, and 10. But remember, we said we're doing this out of order because I want you to be a little bit more ready for the SAT next week. So, we have already covered these learning targets before, which was all the review of probability stuff. I'm pretty sure that's going to be on the next quiz. Okay? Quite sure. Hey. Oh, okay. Gotcha. The stuff we're going to cover today, guys, is the 11.2 stuff that's on that sheet in front of you. We're going to talk about binomial probabilities to start off with, and then hopefully do some probability distribution stuff. We'll see how far we get today, okay? Basically, the goal is to get through most of this packet this week, okay? We're just going to go as far as we get every day. All right, so our next summative is Thursday next week. So Tuesday is the SAT, okay? So this week we're going to go through the packet. Monday I'm setting aside to finish up any of this we need to do, but also just have a test prep day where we just like talk about testing strategies. Tuesday is the SAT. Wednesday we're going to review everything, and then Thursday we'll take the summative, because then Friday is in the afternoon. All afternoon on that Friday is the career con thing. So I won't have my 7th period, so I'm not too sure what I'm doing with 3rd and 4th, but we'll figure something out, okay? All right. Yeah, we'll see. Maybe we'll get a head start on something, just a little bit of the next lesson, so that they're not, you guys can get ahead. What? All right. Ready, guys? Okay. Okay. We're 2 minutes into the recording, and I've got nothing yet, so yeah. All right. Binomial probability. We will do parts of this. We would have, if we'd done chapter 10 first, we would already have seen some of this, okay? We're going to talk about Pascal's triangle later and how it's used to do binomial expansion. But for today, what we're talking about is binomial probability. A binomial probability is where there's 2 outcomes, okay? Now, that seems pretty understandable. What bi means 2, right? But it seems understandable when we're talking about like heads or tails, true or false, right? But it's actually applicable to a lot more than that, because 2 outcomes can be success or failure. Okay, so if we have a multiple choice test with 5 choices, the chance of guessing correctly is 20%, right? 1/5. So the chance of success is 1/5. The chance of failure is 4/5, or 80%. Okay, so that can still be considered a binomial experiment, because it's either you succeed or you fail. It's not always just there's only 2 possible outcomes. It's we're looking at 2 things like success or failure. All right, it's this crazy formula here that your calculator does for you, but we'll talk through this, okay? It says when you have n independent trials, for example, 10 question multiple choice quiz, okay? 10 would be the n. The probability of success is p. So for our example, 20%, right? Because there was 5 choices. The probability of failure is 1 minus p, okay, which they call q. And then the probability of x successes. So for my example real fast, If we had 10 questions, n would be 10. If we wanted to pass, which would be 6 right. I'm going to just go with exactly 6 right, okay? We'll talk more about that later. You would say, I'm going to see 6. Probability of getting it right is 0.2 or 1/5, yes? And we want to get 6 right. Probability of failure, what did we say? 0.8 or 4/5, right? Because there's 4 wrong answers for each question. How many do we want? If we want to get exactly 6 right, we want to get exactly 4 wrong, which is where this comes, total minus the number of successes. Okay? Well, if you're guessing on all of them, you'd just be happy if you passed, right? Really happy? And the probability of that happening is actually very low. Okay, real fast, do you remember where to get this C thing on your calculator? Okay, math, I like to arrow to the left, but it's under that probability menu somewhere, and it's number 3, okay? Now, thank you, don't have, so I have to put 10, then go there. I don't have that new operating system. You all can do this much better than me, okay? And then I'm going to take that answer, did we get 210? And then times 0.2 to the 6th times 0.8 to the 4th. So the probability of successfully getting a 60% and passing this is 0.5%, okay? Now, it would increase infinitesimally if we said, well, you could get 7 or 8 or 9 or 10 right, and that would still be passing, right? But this is the chance that we pass with exactly 60%. And when I say it would increase a little bit, the chance of each of those happening is going to be even less than this, right? But if it was okay to pass with 6, 7, 8, 9, or 10 right, you'd add all those probabilities together. All right, I'm getting ahead of myself. Let's move on. You picked up the reference sheet at the door. This is on the reference sheet, okay? Everybody see it on there somewhere? All right, we're going to talk about how to do it on the calculator eventually, and that is also here. All right, so here's our first example. Let's do this one by hand. A golfer can drive a ball to the fairway about 70% of the time. What's the probability of hitting the fairway on exactly 14 of the 18 holes? Okay, so what's N? Total number of experiments here, 18. X is the number we want to be successful at, which would be 14. Probability of success would be 0.7, and probability of failure would be 0.3. All right, so we would do 18C14 times 0.7 to the what? How many times do we want to succeed? 14. And then the probability of failure, which is 0.3, and we want to fail exactly 4 times. Okay? Math. 14 times 0.7 to the 14th times 0.3 to the 4th. Anybody else? 0.168. Okay. Let me show you how to do that without doing it by hand. Your calculator will do this for you. It is under second vars. Now, second vars, okay? But you have to scroll down to the one that says Binom PDF. Everybody find it? Not CDF. We're going to do PDF. Now, if you have an older calculator, you have to put these things behind it separated by a comma. So the number of trials is how many? 18, and then you would type comma if you have an older one. The probability of success is the second thing it wants, which is 0.7, comma if you have the older one. X is how many you want to get right, which is exactly 14. So when you paste, this is what it's going to look like on your screen, 18, comma, 0.7, comma, 14. If you have the older one, you just type it that way to begin with. Then you hit enter, and it's the same 0.168. Are we good? Okay, and again, on your reference sheet, guys, it says that right here. Do you see this? Okay. And it doesn't tell you where to, oh, it even says it is under the distribution menu, okay? So it even tells you where to find that. That's right on the reference sheet. So let's try this one. The probability that a substitute teacher has to work on a Friday during any given week in a certain school district is 32%. What is the probability that the substitute teacher will work on 3 of the 4 Fridays in the upcoming month? So N is, how many trials are we looking at, or how many possible? 4. How many times do we want it to happen? 3. Probability of success, 0.32. Probability of failure, 0.68. Okay, so you could do this, 0.32 to the what? Anybody get how it goes? No? How many successes do we want to have? 3. How many failures? Because it's the one remaining, right? Okay. Or how would we do it with that? Make sure you're using the right thing. It's Binom PDF. What goes in first? Do you remember? Or if yours probably tells you, but number of trials, probability of success, number of successes you want to have, right? I'm going to do it that way because it takes me a lot less time to type it in. What was it? 4.32 and 3? 0.089 or 8.9%? So the question asked, what is the probability the teacher will work on 3 out of the 4? So there's only a 9% chance that this sub will get a job 3 out of the 4 Fridays. All right. On average, a basketball player misses 3 free throws out of every 8 attempts. If the player attempts 5, what is the probability that he misses no more than 2? Okay, guys. So in order for this to be successful, he can miss how many? Could miss 2 or 1 or 0. Yes, there's 2 ways to do this, okay? But we're gonna do it separately first. So N is attempts 5, right? This is a little bit confusing. The 3 out of 5 is to be able to predict what? Why is that misses 3 out of 5? That's your probability, right? That's 3 out of 8. Thank you. Misses 3 out of 8. So do we want to do makes or misses here? We got to think about this carefully. Want to do miss? Okay. If we're going to call a success missing, or are you going to call it success making is the problem? I'm going to do success is making? Okay. So the probability of success is, what's the chance that he makes it? She, he. 5 out of 8, right? Probability of failure, 3 out of 8. And we want to succeed, be careful, how many times? Misses no more than 2. Shooting 5, so we want to make how many? Make 3, or make 4, or make 5. Okay. So I'm going to use that button again. Nor Binom PDF. Make sure it's Binom. Okay. And then I'm going to say 5 trials. Probability of success is 5 out of 8. And we want to succeed 3 times. The probability of that happening would be 0.343. Okay. The probability of, I'm going to just do second enter. And what do I want to change this time? Just the last number, right? Can be 4 times. The chance that you make 4, does that make sense? That you make 4 goes down a little bit? That he makes all 5? Okay, so now what do we want to do for this question? Because we're successful if he misses no more than 2 times. We're going to have to add all those up, right? So we're going to say this one plus this one plus this one. I got 0.724. Did you get roughly that when you added them? Okay, now, so about 72% of the time, this player will miss no more than 2. Now, there's another way to do this, okay? On your calculator, it's a combined probability. Remember, there was PDF, there's also CDF. So if you go to second vars and you go down there to CDF, now the problem is, if we put in out of 5 trials, chance of success is 5/8. This counts down, okay, or less. So what you would have to do is say, I want to succeed how many times? Well, what you would say is 2 and down, and then you'd have to do 1 minus that. Let me explain that again. There's our 0.72 number. It counts down. It counts, if you put in a 2, it adds up 2, 1, and 0. Okay? We want it to add up 3, 4, and 5, right? But it won't do that. So if we have it add up 2, 1, and 0, that's really the chance that we don't make it, right? So then it's 1 minus that. It's confusing, okay? That's why it's probably better, unless it's some great big huge number, to just add them up one at a time, okay? We will do some more of this later. All right, these are the 2 problems I want you to do on this concept tonight, okay? Just 2 problems. I have multiple parts, I know. All right, now we're going to take a little commercial break and review some really basic stuff. Mean, median, mode. Yes, we know this stuff? Okay, tell me what a mean is. Okay, you add them all up and divide by how many there are, right? Just like when you find a midpoint. Oh, wait a minute. All right. The median, how do you find the median? Okay, but before you find the middle number, you got to put them in order, yes? And what if there's 7 numbers? Then it's the 4th one, right? But if there's 8 numbers, you have to take the 4th and 5th number, because the middle 2, and add them together and divide by 2, because it's got to be exactly half above and half below. Does everybody understand that? So even if the number isn't on the list, half of them will fall below and half will fall above. Okay, and the mode is the number that occurs most often. There can be more than one mode. There can be no mode, In other words, they all happen once. Okay. All right, I'm going to skip a bunch of these slides. The other thing, range, guys, max minus min, we've talked about that, right? Okay. So could we do this one by hand, maybe just in our head? Can we add those up? 5, 10, this is 30, 47, is that right? Anybody get 47? Divided by 6? Is that what there are? 6 of them? I don't know what that is. 7.8, okay. So the mean, and we're going to do this in a minute, but on the calculator, the mean, this is the symbol they're going to use for mean. And we're going to, it was what? 7.83, okay. The median, these are in order, so I picked these. The median would be here. So if we added those two and divided by 2, we'd get 6, okay. And this one doesn't have a mode. All right. The spread or variation of a set of data, okay, describes how far it's spread out. 3 measures of spread, range, variance, and standard deviation are used, okay? The formulas for population and variance and standard variance use how far it is off of the mean, okay, how far a number is off of the mean. They will square it because you have to have a positive. Does that make sense, guys? If I have some numbers that are above the mean and some numbers that are below the mean, those would all cancel each other out if I left them positive and negative, okay? We're going to use our calculator. This is the symbol that's going to be the mean. The standard deviation, there's 2. On your calculator, there's this one and there's this one, okay? On all of this, one is the sample standard deviation and one is for a population standard deviation. I'm going to talk about the difference very briefly, but on the quiz, I wrote next to the blank which one I wanted, okay? That you take Prob and Stats if you want, or AP Stats if you want to spend a whole bunch of time on that. Okay, variance is the average of the squared differences from the mean, which is the standard deviation squared, okay? So to calculate the variance, guys, you'd find the average, then you'd figure out how far away each number is from the average. Okay, square those and then average that. And it's squared because it has to come out positive. All right, so this formula looks crazy, but you subtract how far it is away from the mean, then you square those, each of those numbers. Then you add them all up. That's what that symbol means, right? Anybody know that symbol? Have we done that symbol, summation? Okay, we're supposed to have done this, the sum and sequence chapter before this, but we didn't. But this means sum, you add them all up, okay? And then you divide by how many of them there were, and if you want the standard deviation, you have to square root, because remember we squared them all. You don't have to know this, okay? It's all done on your calculator. The population standard deviation is this one. The sample standard deviation is this one, sample S. We can remember that, right? Basically, it depends how the data was collected. If I wanted to know the standard deviation in this class, then this class is the entire population. Does that make sense? If I wanted to know the standard deviation for everybody who took the last quiz, and I used this class to figure that out, that would be a sample. Does that make sense? Because I just used part of the total. All right. When they use a sample, they divide by a slightly smaller number, n minus 1 instead of n, to take care of the fact that it is a smaller population. All right. We are going to move on, or a subset of the population. I'm going to skip a whole bunch of this because I just want one. Oh, here, just real quick. In a given set of data, the majority of the values will fall within 1 standard deviation of the mean, and almost all of them fall within 2. Okay? We're going to talk on Friday about normally distributed data. and what that looks like. All right. And the 5-number summary we're going to look at tomorrow. So we're skipping that slide too. All right, so I want you to just do this one. Can you go and put these in a list, these numbers right here? Just want to do one example, okay? The grades of 10 students in a math class are listed below. I'm certainly hoping these are not percentages. I don't know about you. I hope it's on a quiz out of 50. Sure, we'll go with that. Even then, it's not good. But, hey, stat enter up onto the title. So arrow up and hit clear enter. Remember to get everything out of there. We've done this a million times, right? 45. I won't read them since you're all ahead of me probably. Oops. I would really feel better if some of you had a calculator in your hand, because I'm going to assume you all know how to do this. And if you're not in AP Stats, it's been a while since you did this. You did it in... Okay, why does it say down here L111? It's looking for, notice it's blank behind that. It's looking for you to enter an 11th term, okay? So that means I've entered 10, which is good because that's how many I was supposed to have entered. Okay, it's stat. Okay, arrow to the right. And we have only put in one list, so we're going to do one variable stats. So it's just number 1 there. Stat, arrow to the right, choice number 1. Now, an older calculator will not have this. On your calculator, we did not put a frequency list in. We will eventually do frequency lists, okay? But you don't want anything left in this frequency list. You want to make sure that's blank for now. But we put in list 1, and then we're just going to go down to calculate. All right. The mean is this first one. The second one is the sum of all the numbers. The third one is the sum of all the squared values. Then what did the S stand for? Do you remember? Sample standard deviation. Okay. So if you went about 11 on either side of the mean, you would hit most of the values, okay? The population standard deviation is this one. But I know what that guy's called, sigma, is that right? Okay. N is the number of items. It's always good to double check that that's the number of items you think you're supposed to have. We're going to tomorrow scroll down because there's more information down there, okay? That's the 5-number summary. Any questions? All right. I am now on the top of worksheet 8, okay? In the previous lesson, well, we didn't do that lesson. Well, we kind of did. We talked about mean, median, mode, okay. A random variable represents a numerical value assigned to an outcome, okay? So random variable sounds really confusing because it's really not a variable, it's a number. If you see random variable in a question, just kind of skim over it and read the rest of the question, and I think you'll get what it's asking, okay? But the kinds of data we talk about can be discrete or continuous. I could ask you this question on a quiz, okay? Discrete means it takes on a finite or countable number of possible values. How many car accidents there were, how many ice cream cones you sold, how many pair of shoes in your closet. Okay. A continuous random variable means that you could measure it in smaller and smaller, break down the intervals smaller and smaller. Number of miles driven. Do you see that you could answer that as straight up miles, or you could give me point, to the nearest tenth or to the nearest hundredth? Okay. Time, you can measure smaller units. Weight, you could measure in smaller and smaller units. Okay, these can be very tricky to tell the difference between. I do hereby solemnly swear I'm not going to ask you a very tricky one on the quiz, okay? Just think to yourself, is this something I can measure in halves, or is it something I have to measure in wholes? That's pretty much going to be my question, okay? So discrete, You're going to measure in whole numbers. Anything you could break down smaller is continuous. So their example says weight on a cereal box, continuous. Number of cars in the parking lot, discrete. Make sense? Time it takes to serve fast food customer, continuous, because I don't know, at most places, McDonald's has a like to the nearest tenth of a second or something, right? How fast they give you your food. They keep track of it for themselves. Attendance at a monthly school board meeting, discrete, because it's a whole number of people, okay? So the 2 on your worksheet represents the time it takes to classroom to go from 68 to 60. So it's time, so it's continuous, because I could say to the nearest hour, to the nearest minute, to the nearest second, right? Represent the number of photos taken by a photographer working a wedding, discrete, going to give you a whole number. All right, moving on. We are now down to probability distribution, okay? It says probability distribution or a random variable x is a table, equation, or graph that links each possible value of x with its probability of occurring. Okay. So the question we were just talking about a minute ago, they could make 5 free throws, 4 free throws, 3 free throws, 2 free throws, 1 free throw, or 0 free throws, right? If you took and you put that in a table and you said, what's the chance he makes 5? What's the chance he makes 4, 3, 2, 1, 0? If I added all those up, it's going to add up to be a total of 1, right? Because that's the probability of each separate one. So it has to total the probability of 1. Okay? That table is a probability distribution. So here's a quick example, but this is using a frequency, guys. Okay, on a teacher evaluation form, students were asked to rate the teacher's explanations. 1 was the teacher gives 2 simplified, like kindergarten explanations, or 5 is they're too technical, can't understand them. Okay, how many people were asked? The frequency is how many people were asked, okay? So 1 person said the teacher scored them a 1, too easy. 8 people said a 2, 20, blah, blah, blah. 5 people said too technical, a 5. So this, did someone total them? 50 it says over here, okay? 50 people were asked. So the probability of scoring a 1 was 1 out of 50. The probability of scoring a 4 was 16 out of 50. Everybody good? If you ask a random student. So then they made this little probability table. So out of the 50, okay, 1 out of the 50 said they gave the teacher a 1, etc. This is also a way of distributing it, showing the score, okay? If you add these all up, the probability of the teacher getting a 1, 2, 3, 4, or 5 from a random student has to total 100%, right? All right, the probability, to find the mean or the average of those scores, okay, you can use the calculator and that frequency list. And you can also do the standard deviation using that same frequency list. Once you do the mean, it's going to do all of them, okay? Mean, etc. So for the example I just did, guys, I would put this in list 1 and this in list 2, and then I would say when I went to one variable stats, I would say list 1 and my frequency list is in list 2, and then it'll calculate the mean and the standard deviation based on the fact that some of those answers were given more than once. Okay, I feel like making you do it the long way once so you understand how much time this saves. What would the long way be to put this in? How would you put this data in if I had to make you put it all in one list? You would type 1 once, and then you would type 2 how many times? 2, 2, 2, 2, 2, 2, 2, 2, 8 times. I have no idea. 1, 2, 3, 4, 5, 6, 7, 8. Then you would put in 3 20 times, right? Until you had put in all 50 of these scores. Do you understand? You have to understand what's going on here. Okay. The frequency list is taking care of that for you. All right. I have an example here I want us to do. This is number 3 at the bottom of page 8A. We are going to put this in. So we're going to go stat, enter. It's very short. Stat, enter. Clear out list 1. So up onto the title, clear, enter. Anybody delete their list 1 yet? Okay. 0, 1, 2, 3 goes in that list. The frequency list is going to go in list 2. Make sure you have list 2 there. And you're going to put in 6, 5, 3, and 1. Okay, so how many people did this talk about? How many total? 15, right? This is 15 people. What is the data about? I need to... Number of medical tests that 15 patients received. Okay, so 6 people got no tests done, etc. Okay, one person had 3 tests run in one day. Okay, now there were 15 people asked. I did not make you enter 15 things, right? Because we put the number of times they occurred in list 2. So now you go stats, arrow to the right, one variable stats. Now, if you have an older calculator, you're going to type second 1 to get L1, and then comma, and then second 2 to get L2 as your frequency list. For the rest of us, we're just going to go down here and do second 2 to get L2 in that spot for the frequency list, and then hit calculate. Okay, now let me... If I do second enter, this is what you should be seeing. One variable stats L1, comma L2 if you have the older calculator. Everybody good? Just kidding. There we go. Did you get this? So what was the average number of tests? The mean was what? Oh, it says calculate the probability distribution. We skipped that totally. All right, we're going to do that in a minute. Oh, I already have those on the screen. All right. So the probability distribution, how are we going to do that? Well, let's just do it right off of this table. I'm going to cheat, okay? What's the chance you got 0 tests done? How do you find that? Okay, so 6 out of 15. 6 out of 15. The chance you got 1 test was 5 out of 15. 2 tests was 3 out of 15. And 3 tests was 1 out of 15. And what are those decimals, Ariana? Okay, so if we did a little, we had 0, 1, 2, or 3 tests run, 0 tests, and then you would do up this, these are number of tests. So the probability would go this way, probability distribution, 0.1, 0.2, 0.3, 0.4. So 6 out of 10 goes up to 0.4. 1 test is 0.3. 2 tests run was 0.2. And 3 tests run is less than 0.1. So that would be the probability distribution. Everybody good? Probably not going to make you do one of those on a test or quiz. Now it says find the mean and the variance and the standard deviation. I jumped ahead and we did that already. These are the numbers off your calculator. Everybody got those? What is the mean? What does that mean? On average, each patient received 1 test. Okay? Had one test run on them. The standard deviation, well, if we consider this a sample, it's not that much. It's about 1, right? The standard deviation either way is about 1. So basically, almost everybody falls within 1 test of that. So if the average was 1 test, almost everybody had from 0 to 2. Okay? Does that seem true on our chart? Yes. And that's what you would say. Almost everybody falls within 1 test of that answer. Okay, moving on. All right, probability distribution. Okay, so now we're going to talk about probability binomial experiment. We've already done binomial experiment. We started the day with binomial experiment. We're revisiting this, okay? So we're going to go to, all right, this is the top of 8B. All right. A survey found that 20% of Americans have visited a doctor in the last 6 months. 5 people will be selected at random and asked if they visited a doctor in the past 6 months. Construct and graph a binomial probability. So what's the chance out of those 5 people that 0 say they went to the doctor, 1 person said they went to the doctor, 2 people, 3 people, 4 people? So your book did this and has these probabilities, okay? They rounded excessively, in my opinion. So what's the chance that out of those 5 people we asked, the person we pick, what's the chance that they say they went twice to the doctor? 20%, right? What's the chance? Oh, no. This is out of the 5, 2 people went to the doctor would be 20%. Okay, I worded that wrong. What is the chance that at least 4 people said they went to the doctor? What would you do? At least 4 people said yes. You'd add up the 4 and the 5, right? Which these, if you went out further, would actually add up a little bit more. All right, we will continue this tomorrow. Guys, this is what you need to do for homework. Okay, 27 and 28. And this page 671, you really are able to do that. I thought I had that run off somewhere. Okay, let me stop the recording.